It's
It's going to take a couple weeks. So we're going to graph rational functions now. Today's rational functions on this notes page and on whatever assignment. We're not going to probably get to like a homework assignment today. But your notes today are going to consist of rational functions like the front page. Could you look, I don't mean to insult your intelligence, but could you look at the front page and then the back page and tell me kind of what changes?
the amount of stuff.
There's something about every problem on the front that's the same.
The
one on the front, there's an exponent
There's an exponent only in the
denominator. Top one, there's exponents in both.
Do you mean variable?
Variable.
Right, good. That's kind of what I'm going for. So just to be clear, what I'm going to try to do on page one here, and I don't even know if we'll do all four of them together, but I had eight, just thought let's do eight in case. So the point I'm trying to get across on the front page is different than the point I'm going to try to get across on the back page. They're related to each other, but you made that connection. You see that on the front page, it's just a number over XY stuff. And then on the back page, you can see now that it's variable stuff over variable stuff. And so it changes a lot of things. So the back page is going to be a little bit more complex than the front page. Let's get to the front. Anyhow, I'll just show you real quick. I'm going to use Desmos and just show you what the family of functions generally looks like. It'll save a little bit of time. I've got nothing against using Desmos. I've said that before. So if I just did like the parent function, which I've messed this up before, Lord knows I'm not the best at saying what the parent function is, but by my estimation, the parent function would be something simple like 1 over x. And who knows, maybe it's weird like 2 over x or something. But the point is that this is what your graphs today are going to generally start to look like. And you'll notice a couple things. First off, it has two parts. They're not connected. So this is not a continuous function. Okay, it has a discontinuity. And how many asymptotes do you see? There are only two. And one of the asymptotes lies horizontally at 0 in this case. And one of the asymptotes lies vertically at 0. Do you see what I mean by there's only two? So you can view that asymptote, like in this case, essentially the x-axis just serves as a horizontal asymptote. If I were to take this function up in the corner, sorry, it's so small. If I took it and I did like -3, watch what happens to the whole graph. It literally shifts the whole graph down. And now the horizontal asymptote is no longer located at x equals 0 or y equals 0. It's now located down at y equals -3. All right. And I could, of course, achieve a different effect if I took and did like a +4. Now the horizontal asymptote is moving upwards instead of downwards. Any guesses as to how I can shift the vertical asymptote? Pay attention if you would, please. Any guesses on how I could move the vertical asymptote sideways? Good job. And you've kind of got that already from our prior experiences, is that if I take the argument itself, and it's that part that's hard to see, but it says 1 over x. I don't think I can zoom. I can zoom a little bit. If I take just the x and that's where I put my manipulator number, like a -2, what's a -2 going to do? Nope. It's going to move it right to like this. And so anytime we're taking the actual argument of the function and putting a plus or minus, that's when we're moving the function or the graph right or left. And of course, you can put it all together. I could do like a +3, which would move the vertical asymptote to the left 3. And then I could put something after the fact, like a +1, and move it up 1. But all rational functions like this are going to have at least two asymptotes. That's kind of a lie. Bless you. All rational functions of this format are going to have these two types of asymptotes, one horizontal and one vertical. And they form the skeleton. I kind of view the graph as like the skin, which is kind of Silence of the Lambs, creepy, morbid, but like the skeletal structure is the asymptotes, and then the graph hangs on those asymptotes in a manner of speaking. So that's what we're going for here today, is we're going to make graphs that generally look like this. They got two arms that oppose each other. But as we move into harder rational functions, our arms might actually both be up, or they might both be down. We'll even see some rational functions where you have an arm up in the corner and then another like parabolic section in the middle and then another arm over there. So over the coming days, they'll get more and more complex. But today's I'm trying to cut from pretty similar chunks of cloth. So that's what they're going to look like. Let's get back to it. So as far as I'm concerned, and by the way, it does say to identify the asymptotes. It also says to identify any holes. I'll talk about what those are as we go in the moment, okay? But let's start on problem one by identifying this. Is there a horizontal asymptote? And if so, where is it? It's down one. Very good. And so we know this is where you really should now listen and not be distracted. If this is all the function was, it would have a horizontal asymptote right at y equals 0, aka the x-axis. But astute observation, because there's a -1 at the back, what it does is it takes the entire structure of that graph and shifts it down one. So we should agree that there is a horizontal asymptote right there. I would sketch that if I were you. If you have any colored writing utensils with you today, I would encourage you to use them. So again, if you put 1 in place of x on the bottom, that's where what we call a discontinuity happens. You know, it's one of the first things you learned when you got to like junior high school or middle school, whatever, is that thou shalt not divide by 0, right? And so putting 1 in is a bad guy. Therefore, that's where something is going to happen. In this case, that something is an asymptote. So we're all going to go over to 1 to the right, and we're going to draw a vertical asymptote like this. The instructions say to identify horizontal and vertical asymptotes and holes. So what we would do is, and it's fine, you should start abbreviating things. We could say horizontal asymptote. It's great if you know how to spell it, but honestly, we'll just save a little time. So HA is a good accepted sort of abbreviation for that. And we're going to say at, not equals, but at y equals -1. Remember that a horizontal line has an equation of y equals. You remember that from the old algebra days. And then we're going to say VA for vertical asymptote at x equals +1. I almost am hesitant to even talk to you about what holes are until we get to the back page. So maybe I'll hold off on this. Hold off on the holes. Let's go ahead and bypass the holes for now. And let's just talk about, okay, fine. Now, how do I make a graph? This is where really it comes down to just what you're going to spend a lot of your time doing is just trying to figure out where generally the points are. You already know what the shape of the graph is going to look like. That's the purpose of those few minutes on Desmos, was to get you comfortable with that. What I need is just some points. I understand those asymptotes. I understand that the graph is going to kind of hug up to them, but it would be nice if I had a point. So let's just say, for example, that I took the number 2 and I put it in place of x. Get good at this. You don't need to make a formal table if you don't want to. It's fine. But if you put 2 in place of x, 2 minus 1 is 1. 4 divided by 1 is 4. 4 minus 1 is 3. This becomes huge when you're talking about rational functions, any functions for this matter. But honestly, to be able to graph something is a matter of playing connect the dots. And if I can start to find some structure, that's what I'm looking for. What if I were to say put in 5?
0,
Five.
yeah.
Right. 5 minus 1 is 4. 4 divided by 4 is 1. 1 minus 1 is 0. And what I'm doing is I'm creating enough structure that I can start to connect the dots. I'd like a little bit of structure in between there. So how about we pick 3? 3 minus 1 is 2. 4 divided by 2 is 2. 2 minus 1 is 1. So 3, 1 is a point on the graph. Quite honestly, that's enough, right? Like I know what generally a rational function is going to look like. It's going to approach the vertical red line asymptotically, and it's going to approach the horizontal red boundary asymptotically. So the hard part becomes, and it's especially hard for me on this board, but you've got to now connect these dots with a smooth curve. And you're always trying to show that analogy I keep using of the plane coming in that can never land. It's trying, like, I don't know if this is a lie or not, but I might take points off on myself if this were a quiz, because the graph does not come back up like one of those what are they called? C8s or the C1 C130s. Have you seen those C130s at the Air Force, the Air Guard base in Cheyenne, how they come in, but then they just go right back up without landing? Have you seen those?
Yeah.
Like your graph doesn't do that. And so I might ding myself for my little lazy. It's hard to say. But anyways, you want to get really good at the plane coming in for a landing. And honestly, if you just make it flat at a certain point, that's the best you can do. Like you get down close to that asymptote and it just starts to ride flat. All right. But now we got to consider that there's another arm to this rational function. So we need to consider now what's happening to the left. And what this becomes a game of is, does the graph structurally exist up here where the green is at, or does it structurally exist down here where the red is at? And so rather than jump to conclusions, we just need a little bit of something to go on. So we're going to pick a number that's to the left of the asymptote. Sure. And I honestly, though, I can't even think of a better number than 0. Not going to lie. I think 0 is pretty sweet because if I put 0 in place of x, what's 0 minus 1?
-1.
And what's 4 divided by -1? And -4 minus 1 is -5. And what were you guys saying? What else did you have?
-5.
-5 is fine. Actually, I hate -5. It's going to make a fraction. So what else? I like -3. That's the only sensible one I've heard. You're trying to avoid fractions. And honestly, you're big kids, so fractions aren't going to keep you up at night. But if I can milk the whole numbers for all it's worth, I'm going to take that. On the bottom, what's -3 minus 1?
-4.
What's 4 divided by -4?
-1.
-1 minus 1?
0.
-2. So I think I have enough right now to sort of structurally play a game of connect the dots. So 0, -5 is down here. -3, -2 is down here. And you can sort of mimic the other points too, by the way. You kind of understand. If you were to graph it like this, I'd probably get a little bit upset about you're going to have a hard time connecting these dots accurately. I go relative to the asymptote. So I'm going to draw a little green line here. I'm going to zoom in actually, and then I'm going to show you. Do you guys see how this dot is 2 above the asymptote? Then there has to be a homie just like him that's 2 below the asymptote. So like I would say, okay, I would go here and go 2 away, and then I would infer or extrapolate from that there has to be a point right there. If you're feeling like that's something you want to do, you can do it. It's just a geometry situation, like symmetry has to exist. If you want to just keep mathing, keep mathing. It's fine. Eventually, though, you should have enough points to make a curve that is sensible. And that is that. So on this one, we did our job. We listed the vertical asymptote, the horizontal asymptote, and of course, there is no hole. If there was, I would tell you, but that's not a now thing. So that's rational function graphing 101. Any issues with that? Let's pick another one on the front page. Let's not do them all. This is probably gonna be overkill. What else on the front page? Is that 4, did you say? Sure. Let's take a look at number 4. 3 is interesting. They're all would you guys listen? I hate to be this guy. I said, what do you want to do? And then I asked, and then it's like when someone says, what do you want for dinner? And you give them an idea and then they pick the other thing. Do you guys mind if we do problem 2?
Yeah, I do mind.
Okay. Why did I ask my question that way? All right, you little turds. We're doing problem 2. And the reason I like problem 2 for our learning right now is because there's a negative in front of the argument, and that's going to be important for us. So I want you to see what's going to happen. Do you already have any conjectures as to what that negative in front of the fraction is going to do? It's going to throw those arms into the opposite quadrants, I bet. Highs are going to become lows and lows are going to become highs. That's what negatives in that particular position do. So sorry I asked, but I should have just told you we're doing problem 2. First, let's find some asymptotes. Where's the horizontal asymptote? At down 2. Horizontal asymptote is at down 2. By default, in a problem like this, it would be a 0. The -2 at the end just chucks everything down 2, just bullies everything straight down. Where's the vertical asymptote going to be? Left 4. Can't stress enough, and this, again, as the problems get harder and harder over the coming weeks, can't stress enough that you build your skeletal structure first. Find everything, asymptotes, holes, get everything you can before you start hammering points down. All right, let's pick a number for X that's good. And by let's, I mean I'm going to. How about -3? It seems like a random choice, but it's actually not. In the bottom, -3 plus 4 is 1. 1 divided by 1 is 1. -1 minus 2 is -3. That's huge. So -3, -3. That tells me, look at that, exactly what you guys theorized would happen has in fact happened. That normally in the upper right quadrant arm has been shot down into the lower right. Any other good numbers? You already know how it's going to behave, right?
2.
2's fine. Let's do 2. What's 2 plus 4? 6. And -1/6 minus 2. So if I did 2, I get -2 and 1/6. Don't be scared of fractions, right? You guys are all tough. You can handle it. -1/6 minus 2 more is -2 and 1/6, of course. What you see, though, is what you would have expected to see, and that is that when you go to the right 2, there you're actually just down below. Sorry, my asymptote moved when I zoomed in. Your point now just moves a little bit below the asymptote. It's like right here. And it's behaving exactly the way you think it would, and you know how it's going to behave. You know it's going to approach both red lines asymptotically. And so you could also then throw in some bonus points down here. Eventually, what your graph is going to do is go like this.
Just
I'm not too thrilled with that graph, but that's the idea.
I think I'm -2.
Okay. Where do you suppose the will you watch? You said you'll watch this later?
Yeah, I'll try to.
Okay.
Try to means absolutely.
I should have gotten a commitment, shouldn't I? I didn't. Well, yes.
Issuing now or signing legal documents.
You guys have a theory at this point as to where the arm is going to be, but I will say again, it's best not to just chance it. It's best to know for sure. So I'm going to pick a number that's to the left of the vertical line. Give me something.
-6.
-6 is fine. And honestly, I would have picked probably -5, but -6 is going to work just as well. It's going to serve its purpose, and its purpose becomes for us. I just want to know basically where I am. Like, do I go above or below? Like, where am I going to build the little curvy do? So if I do -6 and I put it in, I do the math. And the little purple egg, what's -6 plus 4?
-2.
-2. What's 1 divided by -2?
Negative.
-1/2. But the negative of -1/2 is
Is
positive
1/2.
1/2. And what's 1/2 minus 2?
2.
-1 and 1. So if I go left 6 and then I go down 1 and 1/2, I would be right there. You can kind of see where I'm making a new dot over here.
Mhm.
And that tells me pretty much everything I need to know. But I mean, we knew, sorry that my man, I wish that wouldn't get moved around like this, but I had a point that was like right here, right?
Yeah.
You guys remember that point?
Yeah.
So there's going to be a point just like him across the way. So you can
Yes.
rest assured that there's going to be a point right there. And you already have enough information to make a graph. So to this point in the lesson, you should understand how to figure out where a vertical asymptote is going to be, how to figure out where a horizontal asymptote is going to be, and you should understand the impact or the effect that that negative is going to have on the graph. It's going to just causes ups and downs to switch places. So this graph, when all is said and done, looks like this. So let's head to the back page because I want to make sure that we get some of those before, because I got 18 minutes and these things take time. So front 2, you can finish at your leisure, or we can finish them tomorrow, whatever you want to do. But this is where the difficulty will, I don't know, maybe start. So right away, 5, just boom. There's a ton of stuff going on here. You want to just throw this out? You've been hanging out with me for years. What do you think we ought to do? Throw it out. What do you mean?
Well,
Nate.
I'm actually thinking of something that starts with, and it's not the other one that I really like, and another word that starts with F. I bet we should factor. And the thing about factoring is it's going to open up a whole new world of possibilities for us that allows us to find holes and asymptotes. So let's take the top of number 5 and let's factor. That should be pretty light work. What is the top factor into?
2 and 4.
X plus 2 times X plus 4. And then the bottom, if I've gotten this point across to you, you would, of course, pull out a GCF. So your bottom is going to be 2 times, and I think it's worth it to show what it looks like after you pull the 2 out. It's 2 times X squared minus 2X minus 8. What does that factor down into?
Definitely 4 and 2. Yeah.
So X plus 2 times X minus 4.
Yeah.
Step 1 is always going to be let's factor. Let's factor as much as we can. And then that S word that you said, simplify, becomes in play. We can. And the fact that you can cancel out the X plus 2s leads me to a very important part of this lesson. So this is where I feel like maybe I should have written a speech or something, so I would say things in the right order. This is where we now have to separate in our mind the difference between vertical asymptotes and holes. In math, bottoms of fractions are not allowed to equal 0, right?
Mm-hmm.
You know that. To make the bottom of this fraction equal 0, one of the numbers that is bad is X equals -2. To use casual, simple words, there's something bad happening at -2. Clear? And another number that makes the bottom equal 0 is 4. There's something bad happening at 4. What my job is now is to convince you of the difference between those two types of bad things. One of them is called a discontinuity. The other is called a removable discontinuity. Which one can't I do a darn thing about?
4.
The 4. There is no X minus 4 on top of this fraction that he'll ever get to cancel with. For that reason, there will be a vertical asymptote at X equals 4. And there's not a darn thing we can do about it. However, you will notice that the X plus 2s can cancel out, right? Which means that, yes, there is a lack of continuity at -2, but it's a quick one. An asymptote is like this big wall of death that the graph approaches and like goes, and it screams and it kind of stays close to it. A hole is just a quick little disrespected blip on the radar that the graph quickly jumps over and then continues on its merry way. So we're going to say for the first time here that there is a hole at -2, blank. A hole is not a wall. It's not an equation. It's not a line. It's not an asymptote. It's a point. And all points require 2 parts, an X and a Y. Been saying this since I met you in Algebra 1. If I know the X coordinate of a point, how do I find the Y coordinate? You plug it in. Now, if I plug it into this red box, are you still with me?
Yeah.
This is like the most critical portion of the lesson. If I plug the -2 into that box, what am I going to get? I'm going to get an error on my calculator. The math gods are going to say, thou shalt not proceed. I used to suck at explaining this, and I think last year I finally dialed it in and figured this out. Do not find the Y coordinate of your hole in the thing that you know is going to give you an error message on your calculator. What you want to do, you ready for this, is you want to actually remove the discontinuity and evaluate the function in the post-removed version of itself. The function is no longer what you see in the red box. The function is now what we need to, sorry for the pun, functionally, we need to see it as X over 4, X plus 4 over 2 times X minus 4. Is something bad going to happen when I put -2 in there? No, because I already removed that evil, right, that would have made it happen. So we're going to take -2 and we're going to plug it up in now to the green box. The green box is the good box. So if I put -2 up in there, what does the top equal? -2 plus 4 on top is 2. We're good. And then on the bottom, what is -2 minus 4? -6, and 2 times -6 is -12, which means that the hole exists at the point -2, -1, 6.
That's
Gotcha. Holes on graph paper this size are hard to graph. They're hard to show. So what you're going to do is you're going to go to that point, -2, -1/6, and you're going to draw a hole for the first time ever. You're going to go to -2, and what was it? -1/6. Was there anything else?
No.
If not, then I'm just going to go right here, and I'm literally going to draw a circle, a hole. And now as I build the graph around that hole, it, like I said, it just gets disrespected. The graph basically jumps right over it, kind of flips it the bird on its way past and just keeps going. It's not like an asymptote. Asymptotes are like bossy, right? A hole is just like a little, yeah. You said the word blip, and I love that. That's kind of what a hole is. It's just a little blip. Okay. So let's put in some asymptotes now. And there's one more huge concept that you're going to get out of this problem if I don't screw it up. So, is there a vertical asymptote? Yeah, we already figured out that at x equals 4, we couldn't do anything about that. So I'm going to go to x equals 4, and I'm going to draw a vertical blocker right here. Where the bottom equals 0 produces two things. It produces an asymptote if you can't do anything about it. It produces a hole if you can. Now the question becomes, where is the horizontal asymptote? I'm going to tell you, and then you guys and all your wizarding powers, by the way, I'm going to erase a whole bunch of stuff right now. I'm going to tell you right now, put your brains together, that there is a horizontal asymptote, and it's at y equals 1/2. See if you math geniuses can figure out where I pulled that one from. Yeah, Brenna. Yes, it's the ratio of the leading coefficients. And the reason I could get away with this shenanigans is because the degree on top is 2. The degree on bottom is 2. When the degrees are the same,
It works.
when the degrees are the same, this is the part where you really should listen. If the degrees on the top and bottom are the same, x to the 2 and x to the 2, everything becomes irrelevant in the grand scheme of infinity. But what comes out in the wash is that there's a 1 right here and a 2 right there. This is your first calculus-y look at what we call a limit. This means that as x grows infinitely large, everything becomes irrelevant other than the 1 and the 2. Think about that for a second. Put a trillion in place of x. Put 5 quintillion in place of x. And you get a crap ton over a crap ton that's pretty much twice as big. And the last I checked, a crap ton over a double crap ton is equal to 1/2. Therefore, that's a limit. We put an asymptote there to show that the graph is going to tend towards a y value of 1/2, like this. Vertical asymptotes are never the ones that cause kids to walk up awkwardly to the desk during the quiz and say, I forgot. Vertical asymptotes, everybody gets it. I'll probably never have to talk about it again. If you can make the bottom equal 0 and you can't cancel it out, it's a vertical. Easy peasy. The horizontals have rules, and you just learned one of them thanks to Brenna. Rule number 1, if the degrees on the top and the bottom are the same, your horizontal asymptote will always be at the ratio of the leading coefficients. So if I wrote you some crazy problem like h of x equals 3x squared minus 2x plus 194 over 4x squared plus 11x minus 182. Is there a horizontal asymptote? Where is it? It's at y equals 3/4. Infinity is an amazing, mind-blowing concept. Everything else becomes irrelevant other than that ratio, 3 to 4. Got it? Since the bell's I only have 8 minutes, I have to talk about another thing before we finish this problem. Did you want to finish this problem? Okay, let's finish it. I got to be faster. You guys, you knuckleheads got to quit chatting. All right, let's get this done. So we know there's a horizontal asymptote at 1/2. We already know that there was a vertical asymptote at 4, at x equals 4, excuse me. And now we know that there's a hole at -2, -1/6. All right, let's get to it. So what we basically want to know at this point is like, where's the graph going to exist? And so to figure that out, we're just going to simply plug and chug. And the question is, which one should I plug into? And the answer is, it doesn't matter. 6. That would be the question I would have asked if I was sitting here right now. If I was still listening and I was still awake, I would say, let's just say I want to know what happens at 3. Do I plug it into the function originally, or do I plug it into the one after I removed the x plus 2? The second one's going to be easier, but the first one will yield the same results. But Sutter, you're spot on. So remember, our cleaned up version was x plus 4 over 2 times x minus 4, correct?
Yes, sir.
So I'm with you, Sutter. Like, by the way, if you feel like a challenge, go ahead, plug it into the one that's on the TV. Plug it into the one that was the factored one before we canceled. You're still going to get the same answer if you don't do anything stupid. But yeah, man, let's do this. So if I put in 3 on the top, what's 3 plus 4?
7.
Put in 3 on the bottom, what's 3 minus 4? -1 times 2 is -2. So we can say that there's a y coordinate there at -3 and 1/2.
A little bit more.
So I go to 3, -1, 2, 3.5. It's going to be right there. You should crave now the knowledge of what points are, how are the points behaving in this red oval? That's what you should be thinking right now. So I want a little something, something. I need more dots to connect, right? So I'm not going to make that much of a leap. So let's do 0. I'll take 0. I love 0. So if I put in 0, God, I erased it again. Why? What a knucklehead. Thank you. Such a ding dong sometimes. So if I put in 0, I get 0 plus 4 is 4. 0 minus 4 is -4 times 2 is -8. What does that equal? -1/2. So at 0, I get -1/2. The dots are starting to come together. And honestly, if you just found one of the two in between there, I would be satisfied. Do you guys want to do 2 or 1?
2.
2's fine. So let's do 2. 2 plus 4 is 6. And then on the bottom, 2 minus 4 is -2 times 2 is -4. And what is 6 over -4? -1.5. So at 2, I'm going to go to -1.5. And now that it's really taken good shape. So at this point, if you were to connect the dots, I would have no issues with this at all.
Don't touch the thing.
Don't go over the hole, like skip it. Say something demeaning to it as you fly by. But again, you want it to look like that. You want it to look like you're flying past it, but it has to exist. It has to be there and present and visible so that people know that the graph does not exist at x equals -2.
So where does it go? Is it a black hole?
It's like a black hole. Sure. I'll take it. And then the other side is going to mimic this, but it's going to mimic it sans hole. Like there's no hole on the right side. It's, you don't copy holes over because there's no reason for us to say that there's a discontinuity on the other side. So that's a unique location for the hole. But again, if you just think in terms of like relative to your asymptote, and maybe this isn't an appropriate thing to teach you, but like you can see where the points are relative to the asymptotes. And then you can just use some basic geometry knowledge to mirror them to the other side. But we do need to start with 1 point for sure. We don't know yet if the arm is down, if it's down here or if it's up here. We got to find out. So let's go do at least 1 point, and then the rest we can fudge. What do you want to, 5, did you say? Sure. Let's do 5. So if you put 5 into that down there, you get 9 over 5 minus 4 is 1 times 2 is 2, and 9 over 2 is 4.5. And that should be all we need, because at 5, 4.5, 1, 2, 3, 4.5, I now know that the graph is up here. And you can start piecing it all together. You can start to say, okay, this point was 2 below, 1.5 below the asymptote. I'm not sure that that's actually accurate, but You can start to get
Yeah.
creative and put your points in where they belong. Got it? Let me get started on one more problem just so that I can say I did. I know you're probably over this whole thing, but you now know one rule of a horizontal asymptote. When you get to a problem and you want to know if there's a horizontal asymptote, you ask yourself, are the degrees the same? If they are, your horizontal is at the ratio of the leading coefficients. I want to pick another one. This one, number 6. What do you notice about the degrees? What is the if you, I hope I'm not using that word and you don't know what I mean. What is the degree on top? It's 1 because it's x to the power of 1, right? What is the degree on bottom? If you have a rational function where the degree on top, boy, I hope you're still listening. This is where all the mistakes happen. This is where all the questions come from. If the degree on top is smaller than the degree on bottom, then you have a horizontal asymptote at y equals 0. Now, there is a stipulation that I have to make. That what I just said is true only provided that there is not a plus or a minus in this purple box. Because as we know from page 1, what happens if I have a plus or a minus in that purple box?
That changes.
It physically picks up the whole dang thing and moves it up and down.
Yeah.
So provided that it's just one fraction, a blah 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 with x's stuff over blah blah blah, then if the top has degree less than the bottom, there will always be a horizontal asymptote at y equals 0. Do you see any on here where the degree on top is bigger than the degree on bottom?
No.
I didn't put any of those on there. If that were to be the case, then there would not be a horizontal asymptote. Okay? So there are 3 things that can happen. Let's recap this before we pack up super quick. If the degrees are the same, where is the horizontal asymptote? At the ratio of the leading numbers. If the degree on top is smaller than the degree on bottom, where is the horizontal? At 0. And if the degree on top is bigger, like if you have x to the third over x to the second, where's the horizontal? There isn't one. Good. We made a lot of progress today. Thanks, guys. Obviously, no assignment. We'll wrap this up tomorrow.